Let's try solving a linear system application problem together. In this specific example, we're going to take a look at a rental business problem. It looks like this business is going to be renting out rollerblades as well as bicycles. During one day, the business has a total of 25 rentals and collects $450 altogether. It looks like rollerblades are rented for $15 per day, while bicycles are going to be a little bit more expensive and are being rented for $30 per day. We're going to go ahead and write a linear system that represents the situation as well as draw a graph for the two linear equations. After that, we're going to go ahead and find the total number of the pairs of skates that were rented as well as the number of bicycles that were rented. First, let's start by defining our variables. First, let's let x represent the number of rollerblades rented. And second, let's let y represent the number of bicycles rented. Next, let's go ahead and write two equations. For our first equation, we know that there has to be a total of 25 different rentals, and they have to be made up of being these rentals that were from rollerblades, as well as these rentals from bicycles. So the only two things that could be rented. That being said, if we know that the number of rollerblades rented is being represented by x, and number of bicycles that are rented is represented by y, then we should be able to say that x plus y is equal to 25. So the number of rentals for rollerblades plus the number of rentals for bicycles equals the total number of rentals. This equation of x plus y is equal to 25 represents the number of rentals. While equation number 1 dealt with the number of rentals, equation number 2 is going to deal with the money that is involved with them. We know that on this particular day, $450 was collected in total, and we also know that the rollerblades were being rented at $15 per day, while the bicycles were being rented for $30 per day. Given this information, we could go ahead and write the equation here of 15x plus 30y is equal to 450. Since the rollerblades were being rented for $15 per day, then we would multiply 15 times however many rollerblades were rented. Then we can see here that the bicycles were being rented for $30 per day, so we would multiply 30 times y, which y represents the number of bicycles rented, and these two added together should get us $450 in total, which is the total amount of money they made from all of these rentals. This equation right here represents the money that was collected from all of these rentals for the day. Now that we have a system of linear equations which are written in standard form, let's go ahead and rewrite them in slope-intercept form because that's going to be a little bit easier to graph. So for our first equation, which represented the number of rentals, we have this x plus y, which is equal to 25. If we want to go ahead and turn this into slope-intercept form, which is that y equals mx plus b form, we should go ahead and subtract x from both sides of this equation. Now, if we go ahead and do that, then on the left side, x minus x will be 0, and we'll be left with saying that y is equal to negative x plus 25 on the right side. For equation number 2, we have this 15x plus 30y, and that is equal to 450. If we want to turn this into slope-intercept form, what we'll do first is subtract 15x from both sides of the equation. Let's go ahead and subtract 15x from the left side and the right side. On the left side, 15x minus 15x will cancel out and make 0x. So we're going to have 30y on the left side is equal to negative 15x plus 450. Then to get y completely isolated, let's go ahead and divide both sides by 30 here on the left side and on the right side. On the left side, 30 divided by 30 is going to equal 1y, or just y, and that's going to equal, and on the right side, negative 15 over 30 just simplifies down to being negative 1/2 x, and then 450 divided by 30, that should equal a positive 15. Now let's go ahead and see if we can graph these two equations on our coordinate plane. Now, notice right away that we do have y-intercepts that are a little bigger for our graph, so we have a positive 15 and a positive 25 here. We only have 10 boxes in each direction here, so we got to be a little bit creative. Maybe it will make each box worth 5 here. So we can make this 5, go ahead and put a 5, 10, 15, 20, and maybe go up to, let's go up to 30 just so we have enough space. You can not be too crowded. And similarly, we can do this along the x-axis as well. So let's go by 5s. Again, the numbers along the x-axis represent the number of rollerblades, and the numbers along the y-axis represent the number of bicycles. For equation number 1, we can see here that this positive 25 lets us know that we have a y-intercept of 0, 25. Okay, then for our slope, we should look at the coefficient for x here. So remember that there is a -1 that's in front. So our slope here is going to be m equals -1. You can also think about that as a -1 over a +1 as a ratio, or maybe even +1 over -1. Either way, it's got to be a 1-to-1 ratio. Now keep in mind that each of our boxes here are jumping by 5, so jumping by ones is going to be a little bit difficult to do because we have to go 1/5 of a box. So if you would like to, keep in mind that as long as the ratio is the same, we can rewrite this. So we could even say something like +5 over a -5, or we could think about this as a -5 over a +5. That would also be fine. Again, this simplifies down to just being 1 or -1 anyway. So for graphing this first equation, or equation number 1, let's start by plotting down the y-intercept, which is 0, 25. Let's go ahead and put that right on the y-axis. So I'm going to plot that right up here on the positive y-axis. And we could go down 1/5 of a box and over 1/5 of a box, or we could go ahead and use these over here. So we can actually just go down 1 box and over a box as well. So moving 5 units at a time. And as long as we're going a 5-to-5 ratio, which is still 1-to-1, then that would be fine. So this +5 on top means we go up 5 because it's rise over run, and this -5 means go to the left 5 units. So let's go ahead and go from that y-intercept to go up 5 and to the left 5. Something like over here would be good. We can keep going in this direction if we would like to, or we can go ahead and use this other ratio of -5 to +5. So that means we go down 5 and to the right 5 units. So really it's only 1 box for us since each one is worth 5. So we keep going in this direction of down 1 box and to the right 1 box, or down 5 units to the right 5 units. Keep in mind that these 2 points over here don't really exist within the domain of this application word problem, since you can't have negative roller blades. So what you can do is actually kind of ignore these 2 points along the left side here and just focus on the ones that are in quadrant 1. Drawing a straight line through these points that we've created, this would be the graph for this linear equation. All right, now for equation 2, we have this +15 for our b value. So we know that we have a y-intercept of 0, +15. And then if we go ahead and take a look at the coefficient for x, which is this -1/2, we know that m, or the slope, is equal to -1/2. Now again, we could move that negative and say this is going to be -1 over a +2. That's fine. Or we can say it's +1 over -2, which is also fine. Or if we want to think about moving 5 units at a time, or multiples of 5, since we are skipping by 5 here, we can also rearrange this and multiply top and bottom by 5. That would be -5 over a +10. Or we can think about it as a +5 over a -10. But again, since we are moving, our boxes are by 5, then it might be helpful to move by multiples of 5 for our slope as well. Okay, so if we go ahead and graph here, let's start with our y-intercept of +15. Let's go ahead and put that on our graph. So if +15 would be right over here on the positive y-axis as well. Now for our slope, to get our other points here, let's not worry about using these 1s and 2s because that's going to be 1/5 and 2/5 of a box. Then we can go ahead and use this ratio here of -5 to +10. Again, it's rise over run, so it's going to be down 5 and to the right 10. If we go down 5 and to the right 10, that's really going down 1 box and in the downward direction, and 2 boxes to the right. So again, this is down 5 and to the right 10. Do that again over here. Now we have a few points that we can connect. Drawing a straight line through these few points, this is what the graph for this linear equation would look like. And again, I know I mentioned it briefly earlier with the rollerblades, but keep in mind that our graph really should be contained over here in quadrant 1, just because you can't have these negative numbers of bicycles and rollerblades being rented. So make sure we keep our graphs confined into quadrant 1, where the domain restrictions would apply. So you can't rent less than 0 of each of these different types of things. Alrighty, so let's go back and see what the questions were actually asking here. So it says we had to go ahead and write a linear system, which is what we did over here. This was our linear system. And we also had to graph the 2 linear equations, which we did over here. Again, these were the 2 graphs. One was blue, one was orange, or one represented the number of rentals. That's this one over here. And one represented the money collected. Okay. Besides that, we also needed to go ahead and find out the total number of skates that were rented as well as bicycles. So let's go ahead and see where these 2 graphs intersect here. So if you go ahead and take a look at this one point right here, this is the one location where these 2 graphs intersect each other. This is the solution. So this solution is going to be 20, 5. Okay, that's the ordered pair of where these two equations meet. Again, keep in mind that this 20 is an X value, so it represents the number of rollerblades being rented, and this 5 represents the Y value, which represents how many bicycles were rented. Let's see how much this answer here of 20, 5 makes sense in the context of this problem. So if we go ahead and take equation 1 here, where we have x plus y is equal to 25, we can go ahead and substitute in 20 for x and 5 for y into these two values and see if this makes sense. So substituting in here, we can go ahead and say that x would be 20, substitute that in, plus this y value of 5, so we're going to substitute that 5 in. Would that equal this 25? Well, 20 plus 5 does equal 25, so since that is true, then we can go ahead and say that, yeah, this does make sense here. If 20 sets of rollerblades were rented and 5 bicycles were rented, there were 25 total rentals. Now for the second equation, which represents the amount of money that was collected, let's go ahead and take this x and this y, and let's replace them with this 20 and this 5 to see if this makes sense here. So let's go ahead and say that we have 15 being multiplied by, I'm going to write it over here, let's do 15 multiplied by 20, which is what we got. Let's go ahead and substitute that in for x, plus 30 times whatever y was. We said it was going to be 5. And let's going to see, does that equal this 450? Okay, so again, it was $15 per each of these sets of rollerblades here, so 15 times 20, that should be a total of $300 that they made from renting out these rollerblades. And then if we go ahead and multiply 30 times 5, it was $30 for each of the bicycles that were rented, so 30 times 5 is going to be $150. And if you add 300 plus 150, I guess the question is, does that equal 450? And I think it does. 450 is what 300 plus 150 is. So that does check out. Okay, so in both scenarios here, we can see that the solution of this 20, 5 does make sense. In conclusion, if there were 25 total rentals that were made and a total of $450 was collected, where the rollerblades were rented at $15 per pair and the bicycles were rented at $30 per bicycle, then we found out that 20 rollerblades and 5 bicycles must have been rented out in this particular day. And that just about wraps up this video. If you found it helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.